commutative property of addition. Now, this is a word that people often like to misspell. Communicative is pretty common, or commutative. Communicative is like a disease. We don't want that. This is the commutative property, and we're going to talk about the commutative property of addition. Now, there is a commutative property of multiplication, and we'll talk about that on another video. But for today, just the commutative property of addition. And it looks like this. It's a lot of times in the book, you'll see a plus b equals b plus a. And hopefully somebody explained to you at some point that what this means is that if I have two things that I want to add together, it doesn't matter which order I add them in, I'll get the same sum. And that brings up a couple of things that I need to remind myself about and tell you. First of all, when I add things together, there's a name for those things. They're called terms. This becomes important later. And terms are basically just things that are added. And you'll notice that I say things because you can have terms that are numbers, but they can also have variables as well. Things that are added. It's a simple definition. I would like it if you could pause this video right now and make a note of this, that terms are things that are added. We'll refer to that in future videos. It's important for algebra class. Alright, so anyways, a plus commutative property of addition is a plus b equals b plus a. And the only thing is, this is what they show you in the books, but it's not the whole story. Really, it's perfectly legitimate to say, well, you could have a plus b plus c. And then how do you use this rule? Well, all the rule means is that you're allowed to move things around and you still get the same sum. So, and by the way, the sum is the result of an addition. So whatever a plus b plus c equals, whatever I put over here better be the same thing. And it turns out that, yeah, you can go ahead and switch them around. You can make it c plus b plus a. And that will be the same result. But I don't think you should take my word for it. This is something you can try on your own very easily. I'll try it with you just to give you the idea. 2 plus 3 plus 4. Let's say that those were what I was adding together instead of a plus b plus c. And what if I switch them around? 4 plus 3 plus 2. The question is, when you add these terms together, do I get the same sum as when I add these terms together? And the answer is yeah. 2 plus 3 is 5, plus 4 is 9. And 4 plus 3 is 7, plus 2 is 9. So it turns out that the commutative property is only telling us that you can change the order of things around when you add them together and you'll still get the same sum. It doesn't just say, it doesn't just apply to adding two things together. Now, since it's just changed the order around, it doesn't mean that you always have to go forward to backwards. You can change the order around any way you want. So if we have 5 plus 6 plus 7, you could switch things around and make it 7 plus 5 plus 6. So all the things that you're adding are in a completely different order from how you started. And the result should still be the same sum. So let's try it. Here's 11 plus 7, that's 18. And 12 plus 6, that's 18. Sure enough, it seems to work. So the commutative property says that we can rearrange the way we add things together and we'll still get the same sum. Let's take a look at another aspect of the commutative property of addition. And that is, we might have to deal with other things that are added together other than just numbers. So let me go ahead and start a new page here. Maybe a number plus something like this, x squared. Plus a number times a letter, 7x. And we'll find that occasionally we'd like to rearrange the order of those terms, those things that are added together. And so it turns out the commutative property lets us do x squared plus 7x plus 3. We'll see more of that later on, but I just wanted to introduce this early on to you, that this is one of the reasons we need to know the commutative property. And when you do this later on, it'd be nice if you knew why you were allowed to do it and what property it was. It's the commutative property of addition. Let's just go back and look one more time. Commutative property of addition. Okay, so what else can we do? It also allows us to mix and match terms. If I have something like 5 plus 7x plus 3 plus 2x, I might like to add together this 7x and this 2x and this 3 and this 5. Problem is that all the terms are out of order. But if I put the 5 next to the 3, and the commutative property lets me do that, and I put the 7x next to the 2x, then it makes it a little bit more obvious what I would like to add together. Now, 5 plus 3 gets me 8, and 7x plus 2x gets me 9x. Don't forget that there's a plus sign in between, so they're still going to be added together. And for those of you that want to do things the right way, we'll usually put the term with the variable, like the 9x, first, and then we'll add the 8 onto that. Okay, now there's a whole nother situation, a whole nother problem we're going to run into, and it has to do with subtracting. Unfortunately, there is no commutative property for subtraction, but we're going to work around that. So for subtraction, we're going to look at a rule. It's called the subtraction rule. And what it says is that subtraction is like adding the opposite. And I'm taking the time to write this and say it because I'd like you to write this and at least say it or think it to yourself. Subtraction is like adding the opposite. Now, it'd be nice if you could pause for a moment and write this down. And then the other thing I want to say is we're going to look at the subtraction rule from an algebra perspective. So in algebra, we'd say a minus b. And if that's our subtraction, and then we want to say is like adding the opposite, we'll then say, well, that must be the same as a plus a negative b. So if I have a minus b, it's equal to a plus a negative b. A minus a positive b is equal to a plus a negative b. Another way to look at this is a minus a negative b is equal to a plus a positive b. Again, we're just saying that if I subtract a negative, it's the same as adding a positive. So that's all I'm trying to say. And it might be useful to have a demonstration, see how this works. So let's say we say something like 5 minus 3. That is the same as 5 plus a negative 3. Now, why do we care about this? Well, we'd like to take advantage of the commutative property of addition, but there isn't a commutative property for subtraction. So what we'll do is we'll change our subtractions into additions like you see here. So let's take a look at how that works. So let's say that I have 13 plus 7x plus 9 minus 12x. It would be so nice to have the 12x and the 7x near one another. But the problem is this is a subtraction, so I'm not allowed to just move the 7x and the 12x right next to each other. However, if I make this into 13 plus 7x plus 9 plus a negative 12x, and I'll put that in parentheses just to keep the two signs separate from each other. Kind of keep myself out of trouble there. If I do that, now I have all addition, plus, plus, and plus. That means that I can now rearrange these terms any way I like. And by the way, this term here on the end is negative 12x. So I can do 13 plus 9, and then I can do plus 7x plus negative 12x. And it's legal for me to do that because everything's being added, and there's a commutative property for addition. So then, of course, we get 22 plus 7x plus negative 12x, that's negative 5x. And just to make it pretty, we'll make it 22 minus 5x. We like to eliminate double signs when we can. And usually in algebra we'll write the term with the variable in front of a term without a variable. So minus 5x plus 22. And again, notice that I was able to rearrange the negative 5x and the 22 so that the negative 5x is first and the 22 comes second. Technically, I probably shouldn't have gone through this step. I should have rearranged them first, and then I could have written them out like this nice and cleanly. Okay, so there is some good uses for the commutative property. And there is one last little trick I'd like to show you that we can do with the commutative property. So if I have something like 78 plus 59 plus 22, that problem, it's probably not your first desire to add 78 plus 59, not necessarily two numbers easy to add together, but in your head you might be able to add 78 and 22. So it might be nice if we put 78 plus 22 together and then plus 59, and then that way the 22 and 78 gets us 100. Plus 59, and that's an easy result. 100 plus 59 is 159. So the commutative property has a number of uses where we can benefit from it. One last little thing I will add is that when you use the commutative property, you can move lots of stuff around. So if I have something like even like 8 plus 37 plus 12, I can move this 8 all the way to the other side of that parentheses. Perfectly legal. 37 plus 12 plus 8. And I want you to notice something. Even though this particular equation that I've written here has parentheses in it, we're not using the associative property here. That's something you might have heard of and we'll discuss later. Usually when you see parentheses you think associative property, but not here. Associative property means we change which numbers or things we're grouping together. Here we group 37 and 12, and here we're still grouping 37 and 12. So associative property is not being applied here. We are using commutative because we're moving the 8 from in front to in back. And now one reason that it might be useful to move the 8 here is because it's closer to the 12, and if we can add the 8 and the 12, that's easier than adding the 8 to the 37. Now, we cannot do this yet until we learn the associative property, which will allow us to throw these parentheses away. So I'm going to leave that for another lesson. That's it. We did it. We're done with commutative property of addition. I believe the next thing I'm going to talk about is you'll see another video on commutative property of multiplication, and like I say, we'll also discuss the associative property of addition and multiplication.